We have a big circle here, this one, and it has 4 smaller circles inside it. And these small circles have half the radius of the big circle. So the radius of each small circle is r, while the radius of the big circle is 2r. We have this area A over here and this area B over here, and we want to find the ratio of A to B. So how do we find this ratio? First, you need to find what kind of circles we have here. So we have two kinds of circles, right? The big circle and 4 small circles. And what is the area of the big circle? Let's first find the area of the big circle. So let's call the area of the big circle L because it's a large circle. So the area of the large circle is 2r, that's the radius of the large circle, squared times pi. And that equals to 4 pi r squared. So that's the area of the big circle, the area L. And let's now find the area of the small circles. So each of these small circles, they have the same area, and we call that area S. So these small circles have radii of r, 1r, and we take the square root of r times pi. It equals pi r squared. That's the area of each small circle. So the conclusion we can draw from what we did so far is pretty obvious. The large circle has 4 times the area of one of these small circles. So we can write it down like this. L equals to 4 times S. Now this information takes us to another conclusion. We have 4 small circles here, right? And the large circle has the area that equals 4 times the area of the small circles. So these 4 circles together, they add up to the area of this big circle. But they do not fill this big circle, right? They should have been filling it. They should have filled it, but they don't fill it. So how is that possible? It is possible because the smaller circles are actually overlapping in 4 areas. And one of those areas is here, this area A, and that's also area A, and this is also area A, and this is also area A. They are all equal. And in these 4 regions, the small circles are overlapping, and they are losing some of their total area. And that's why they can't fill this big circle entirely. And the area that these small circles fail to fill, the area that they can't fill, is actually the area B. So the area they are losing because of overlapping is equal to area B. So that tells us that A equals to B, and their ratio is actually 1. But I'm also going to prove that in a more mathematical manner. We named all of these equal regions area A, right? And we also know that these regions are also equal. It's pretty obvious, and this is equal to, and they are all area B. And there's a third type of region here, right? Right here, this region. And let's name that region area C. And we have another area C here, and one more area C here, and one final area C over here. Now let's create some equations using the area of these different regions. The area of the large circle, L, the area L, in terms of A, B, and C. Let's do it. So this entire whole region is the circle L, the large circle. So what does it have inside it? First of all, it has 4 A's, right? 1, 2, 3, 4 A's. Plus, it has 4 B's. 1, 2, 3, 4 B's. Next, it has 4 C regions. 1, 2, 3, 4 C's. So the large circle over here has 4 A's, 4 B's, and 4 C's inside it. And what do the smaller circles have? Let's write that down too. Each one of the small circles, so one of the small circles is, for example, this one over here. This one that you see is a small circle. And what does it have inside it? It has 2 region A's, 2 region A's inside it, and 1 region C. Here, this is the region C, and it has one of that. So we also have this piece of information here. L equals to 4 times S. Now let's combine all of these equations together. So instead of L, first we're going to write down L. We know that L equals to 4a plus 4b plus 4c. This is L over here, the area of the large circle, and we know that it equals to 4 times the area of each small circle. So we also know that the area of one small circle equals to this over here. So let's write down inside the parentheses 2a plus c. Now let's multiply what's inside this with 4. 4 times 2 is 8. It's 8a plus 4 times c is 4c. So we have 8a plus 4c over here. And on the other side, we have the same thing we had up here, which is 4a plus 4b plus 4c. I want to make this quick, so let's just cancel 4c's over here. They cancel because they are the same thing. And we subtract 4a from both sides of the equation. And what we get next is 4a minus 4a is nothing. And we get 4b down here. And on the other side, we get 8a minus 4a, which is 4a. So we've got 4b equals to 4a. And let's divide both sides by 4. We divide both sides by 4. And what we get is, we get this basically. B equals to A. So we've got the same thing up here. A equals to B. We proved that using math. Let's go back and see what the question was. The question was A divided by B. So we know that A equals to B, right? And A divided by B is basically, we can replace B with A now because we know they're equal. It's A divided by A, which is 1. So the answer to our question is 1. We showed it using math. I really believe that this example question should be very useful for you if you want to develop your skills in solving find the shaded area type of questions. So if you also think this video was good, please push the like button and go check out my other videos on my channel. And if you like my channel, you can also subscribe. Have a good day and see you soon.